Welcome you all in lecture number 25 of Engineering Mathematics 1 MTL 1025. In this lecture, we will going to discuss the transformation of beta function, transformation of beta function, okay, duplication formula, and third, examples based on beta function, based on beta and gamma function. Okay. In our previous class, we already studied about the beta function and gamma function. Okay. So let us see that some other form of beta function. Okay. What is beta function? Beta function is defined as integral 0 to 1 x to the power m minus 1 minus x to the power n minus 1 dx. Let us apply one transformation. X is equal to 1 by y, then dx is equal to this one. Now putting the value of x and dy in this integral, then see the limit. X is equal to 1 upon 1 plus y. So if x equal to 0, then y is equal to infinity. If x equal to 1, then y equal to 1. Okay. If x equal to 1, then y equal to 0. Not 1, this is 0. Okay. So the limit of the integral is infinity to 0. And x to the power m minus 1, that is 1 upon 1 plus y to the power m minus 1. And what is 1 minus x? 1 minus x is y divided by 1 plus y to the power m minus 1, n minus 1. And dx is minus 1 upon 1 plus y square dy. Right? So this minus and limit, we can interchange. This is 0 to infinity. And this one is y to the power n minus 1 divided by 1 plus y to the power m minus 1, 1 plus y to the power n minus 1 and 1 plus y square. That is 1 plus y whole to the power m plus n minus 2 plus 2 dy. Okay. So y to the power n minus 1, 1 plus y to the power m plus n dy is equal to beta mn. And see one important result, since beta function is symmetric function, so this integral can be written as integral 0 to infinity y to the power m minus 1 divided by 1 plus y to the power m plus n dy. Why? Since this function is symmetric function, that is beta mn can be written as beta nm. Okay. So this important result we will use later on. Now see, we have to prove gamma of n into gamma of 1 minus n is equal to pi by sin n pi. Okay. See, since we know that beta function beta mn is equal to gamma m gamma n divided by gamma m plus n. Okay. So if we put m plus n is equal to 1, why? See here, this is gamma n and this is gamma 1 minus n. So if we write m is equal to 1 minus n, it means what? M plus n is equal to 1. So this we put m plus n is equal to 1, implies that m is equal to 1 minus n. Okay. Then this beta mn is equal to beta, what is m? M is 1 minus n and n is equal to gamma n gamma 1 minus n divided by gamma m plus n, that is 1. Okay. So what is beta function? Just now we studied that beta mn is equal to integral 0 to infinity y to the power n minus 1, 1 plus y to the power m plus n dy. Okay, so apply this result here, right? What is m? M is equal to 1 minus n. So this becomes integral 0 to infinity, this one, integral 0 to infinity y to the power n minus 1. What is m? M is 1 minus n. Then 1 plus y, 1 minus n plus n dy. Okay, so this is equal to integral 0 to infinity y divided by y to the power n minus 1 divided by 1 plus y dy. And what is this? This is pi by sine n pi. You already studied this thing in your 11th or 12th class. Okay, so you can prove it easily. If you have any doubt, then you can ask me, right? So this integral is equal to pi divided by sine n pi. Okay, so gamma of n into gamma of 1 minus n is equal to pi sine n pi. Next, gamma of n into gamma of 1 minus n is equal to pi divided by sine n pi. Using this result, we can show that this one, okay, for which we have to use here, since we know that gamma of n plus 1 is equal to n into gamma n. Okay, so write it, n into gamma n 1 minus n is equal to n pi sine n pi, and this can be written as, right, what is this thing? This thing is n pi divided by sine n pi, so this can be written as n pi divided by sine n pi. So gamma of 1 plus n into gamma of 1 minus n is equal to n pi divided by sine n pi. Now see the important result. This result is known as duplication formula. What is this? This is the duplication formula. See how we will prove it. What is the duplication formula? First, remember the statement. This is the statement of the duplication formula. Gamma m plus 1 by 2 equal to square root of pi 2 to the power 2m minus 1 gamma 2m, right? And deduce the result, this one, deduce the result, this. Okay, so we know that this thing is beta mn, and beta mn is equal to gamma m, this part is beta mn. Okay, so take this to right hand side, this becomes the beta mn. Okay, write it star. Now see the result. What we have to show? We have to prove gamma m and gamma 1 by m plus 1 by 2. How we create gamma 1 m plus 1 by 2? If this n becomes 1 by 2, n equal to 1 by 2, then the denominator become gamma m plus n by 2. Okay, okay. So putting 2n minus 1 equal to 0. So n equal to 1 by 2. Putting n is equal to 1 by 2 in above equation star. So we get 0 to pi by 2 sine 2m minus 1 theta d theta equal to gamma m, gamma 1 by 2, 2 times gamma m plus 1 by 2. Okay, so gamma 1 by 2 is equal to square root of pi 2 times gamma m plus 1 by 2. Okay, so see this equation is A. Say this equation is A. Again come to the star. On that star, in equation star, in star, putting m is equal to n. Okay, m is equal to n. So in star, if we put m is equal to n, right? Why we are putting m is equal to n? Since see this term, this is gamma 2m. How gamma 2m will appear? If this m and n are equal. Okay, so putting m is equal to n. So integral 0 to pi by 2 sine to the power 2m minus 1 theta. Since m is equal to 1, so cos of 2m minus 1 theta d theta equal to gamma m square 2 times gamma 2m. Okay. Now in this equation, see this equation, what we have to do? Multiply 2 to the power 2m minus 1 and divide 2 to the power 2m minus 1. Okay, so this is the division. and this one is the multiplication whole to the power 2m minus 1. Okay, what is this? This is sine 2 theta. So sine 2 theta to the power 2m minus 1. Okay, sine to the power sine 2 theta to the power 2m minus 1, and d theta, how it become 2 d theta? See here, 2 to the power 2m minus 1. So 2 to the 1 upon 2 to the power 2m minus 1 can be written as 1 upon 2 to the power m and into 1 upon 2. So 1 upon 2 to the power m into, right, 1 upon 2 to the power minus 1 into 2. Okay, 1 upon 2 to the power 2m into 1 upon 2 to the power minus 1, that becomes 2 d theta. Okay, now putting 2 d theta is equal to 5, right? After all, we have to convert into this form. Okay, this form star. So putting 2 theta is equal to 5. So 2 d theta is equal to d5. Then 1 upon 2 to the power 2m integral 0 to pi. Why? If theta is equal to 0, phi equal to 0. If theta is equal to pi by 2, then phi is equal to pi. Sine to the power 2m minus 1 phi d phi. Okay, gamma of m square is equal to 2 into 2 gamma 2m. Okay. Now see, we know that integral 0 to 2a fx dx is equal to 2 times integral 0 to a fx dx. Okay, so this becomes, apply this result here. So this becomes 2 divided by 2 to the power 2m integral 0 to pi by 2. Since 2a is pi, so a is equal to pi by 2. 0 to pi by 2 sine to the power 2m minus 1 phi d phi is equal to this. Okay, so taking this term to right hand side, that is 2 to the power 2m minus 1 in the denominator, multiply this one and say this result is b. Say this result is b. Now see, what is a and b? A and b are equal. Okay, what is a and b? A and b are equal. So if a and b are equal, then their right hand side also equal. Gamma n is square root of pi, this is square root, not gamma, 2 times gamma of m plus 1 by 2 is equal to, right hand side of b is 2 to the power 2m minus 1 into gamma of m square divided by 2 into gamma of 2m. Okay, so after simplification this, we got the required result of this duplication formula. Okay, okay, since this gamma is cancelled by this, multiply this term here, so square root pi 2 to the power 2m and multiply this 2 by here. Okay, this way. See, this is the duplication formula. Okay, now multiplying gamma m to deduce the another result, multiplying gamma n in this equation, say double star. Okay, so gamma m plus 1 by 2 equal to gamma 1 by 2 gamma 2m into gamma m divided by this, right? After solving this term, okay, and simplifying, we got this result. Okay, now we have to prove this result. Beta of mn is equal to beta of m plus 1n beta of m n plus 1. So this is gamma of m plus 1, right? We know that relation between beta and gamma function. Gamma of m plus 1, gamma of n divided by gamma of m plus n plus 1. Okay, yes, and from this also. Now simplify this term. Since we know that gamma of x plus 1 is equal to x into gamma of x, so apply this result here, this one and denominator. Okay, and simplify. The gamma of m plus 1 is equal to m into gamma n gamma of m, and gamma of n plus 1 is equal to n into gamma n, and gamma of m plus n plus 1 is equal to m plus n gamma of m plus n, and taking common terms from the here and simplify this. So this is equal to this one. This is the beta function, right? Beta mn. Okay. Now see the some example. See this example. How do we convert this into beta function? Then beta mn is equal to integral 0 to 1 x to the power m minus 1 minus x to the power n minus 1 dx. Okay. See this result. This result is not in this form. Then what we have to do? We have to convert this into this form. So apply this transformation. Let x cube is equal to sine square theta. Okay. This transformation, how you know which transformation we have to apply? This is done by the practice. So either you put x cube is equal to sine square theta or x cube is equal to cos square theta. Okay. So x cube is equal to sine square theta, and then 3x square is equal to 3x square dx is equal to 2 sine theta cos theta d theta. What is d? What is x? If x square is equal to sine square theta, then this is equal to sine 2 by 3 theta. Okay. Then what is this one? Dx is equal to 2 by 3 sine theta cos theta d theta divided by x square. What is x square? X is equal to this. So this is sine to the power 4 by 3 theta. Okay. This term is dx. Okay. So 1 minus, now what is x cube? 1 minus x cube whole to the power 1 by 2. This is sine square theta, and 1 minus x cube, that is 1 minus sine square theta, that is cos square theta whole to the power 1 by 2. This is equal to sine theta divided by cos theta. Okay. So this one is cos theta sine theta by cos theta into dx is equal to this one. Now simplify this term. Cos theta is cancelled out. Okay. This is 2 by 3 integral 0 to pi by 2. See the limit. If x equal to 0 here, if x equal to 0 implies that theta equal to 0. If x equal to 1 implies that theta is equal to pi by 2. Okay. So the limit is integral 0 to pi by 2 sine to the power 2 minus 4 by 3 theta d theta. Okay. So this term, this integral is compared with this one. 2 times integral 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta. Okay. And what is this? This is beta, and basically this is gamma m divided by gamma m plus n. Okay. So 2m minus 1 is equal to 2 by 3. Right here 2m minus 1 is equal to 2 by 3. Then what is m? M is equal to 2 by 3 plus 1, that is 5 by 3. Okay. This one is 5 by 3. Okay. 5 by 3, no, 2m is equal to 5 by 3, then m is equal to 5 by 6. Okay. So 2m minus 1 is equal to 2 by 3. So m is equal to 5 by 3, 2 by 3 plus 1, that is the 5 by 3, 5 by 3, 2m is equal to 5 by 3, then m is equal to 5 by 6. Now similarly 2n minus 1 equal to 0, 2n minus 1 equal to 0, so n is equal to 1 by 2. Okay. Yes. Now putting all these result m and n here, gamma of n, this one is the 5 by 6, check it, and this is gamma of m plus n, that is 5 by 6 gamma 1 by 2, and this one is gamma of 2 times gamma of 5 by 6 plus 1 by 2, and simplify this term. Okay. Now see similarly how you solve this one. This is the form of beta function. Okay, now we have to convert it into the trigonometric form. So write denominator term is 1 minus x to the power n. So write x to the power n is equal to sine square theta. Then what is x? X is equal to sine to the power 2 by n theta. Then what is dx? 2 by n sine to the power 2 by n minus 1 theta cos theta d theta. Okay. Okay. This one is dx. Now putting this dx and this x to the power n in this integral. If x equal to 0, then theta equal to 0. X equal to 1, then theta equal to pi by 2. Okay. Putting all these result here and compare again 2 times integral 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta is equal to beta mn, and that is gamma of n divided by gamma of m plus n. Okay, and solve this result. You find this. Okay, now see this example. Right, convert this example into two form. This is I1 and this one is I2. Right, divide this example into two parts. This is I1 and I2. Solve either I1 or I2 now by the transformation. See the I2. On I2 apply this result. X is equal to 1 by z. Apply this result. X equal to 1 by z to the power n minus 1, 1 plus x, and dx is equal to minus 1 by z square dz. Yes, this is dx. This one is the denominator term, and this is x to the power n minus. And see the limit. If x equal to 0, z is infinity. If x is equal to 1, z equal to 1. Okay. So this integral is 1 to infinity z to the power m minus 1, 1 plus z to the power m plus n. Change its variable. We know that after changing the variable, value of integral does not change. So this is I2. Now what is I? I is equal to I1 plus I2. What is I1? I1 is 0 to 1 x to the power m minus 1 divided by 1 plus x to the power m plus n dx plus what is I2? I2 initially this one, now it converted into this form. This is 1 to infinity x to the power m minus 1, 1 plus x to the power m plus n dx. Now apply the formula of definite integral, that is a to b fx dx is equal to a to c fx dx plus c to b fx dx. Okay, now this a, b, and this is c. Okay, similarly see a, b, no, then a, c, and this c to b. Okay, so this integral becomes a to b, means 0 to infinity x to the power m minus 1, 1 plus x to the power m plus n dx. Okay, and this we already know that this is the beta function, and this one is gamma m divided by gamma of m plus n. Okay. Solve this thing in the same way, putting x to the power n is equal to sine square theta. Okay. Now this is the exercise problem. You practice these exercise problems. If you face any problem in these exercise problem, then you can call me, right, or write your comment. Okay, we will stop here. In next lecture we will discuss about the double integral, triple integral. Okay.